Hello everyone, welcome to my YouTube channel. Today we will learn about decision tree and we'll try to solve some regression problem. In my last video, I tried to explain the mathematical intuition of decision tree regression problem because when you are solving the regression problem, you are working with a continuous output. So for that, you cannot rely on entropy or Gini impurity. You have to more rely on the variance calculation, right? And in the last video, we showed that how to calculate the variance of each node, and then you can take the decision like which is the highest, and then based on that, you can take a decision that okay, this is the feature I will use for my root node and for split and the next node, something like this. So today is a practical example, and practical example will use the sklearn. So let's start without wasting much time. I'll minimize my screen. Okay, hopefully you guys able to see my screen. Okay, again I'm using sklearn Boston datasets. It's an inbuilt datasets and very famous datasets. It's basically a house prediction datasets. In the Boston locality, it's predicting the house, and all these line of codes are just building the datasets because in the sklearn package, it's in a JSON format because you can see it has a key value pair. And I'm kind of assuming that by the time you're kind of aware in the Python, there are dictionary format. So it's kind of in that format. So again, just this line of code is converting that data into a data frame. So finally, I'm just adding those feature names and then creating the final data sets. Along with the data sets, I'm adding the target variable, which is my price column. So finally, my data sets is looking like this. So up to this, it's very simple. Almost in every regression example, I use the same data set so that it will be easy to explain. And then this is the price column. Then we are just dividing the data into the independent features and the dependent features. So you got this. Next is the train test split. I prefer not to change this things, this logic, so that anytime when you start coding, you can just follow one pattern actually. That's why I'm not changing the data sets or this kind of train test split, all these examples. Um, and then finally, I'm creating the train and test sets. Up to this, very simple, nothing special. Now, what first we are doing, we are just calling the decision tree regression example. Again, I told you previously also, like when I showed the classification problem, Shift tab is your best friend here. Just do a Shift tab and check what are the things that are available. Almost all the hyperparameters you can see here, and max step none mean. If you leave this, then it will go till almost on the all the leaf node. So basically, there is a chance of overfitting. Okay, so we will just leave it right now as it is without making any change, without any hyperparameter tuning. We'll just run it and we use that test data and it will give us the prediction. Okay, and once you have the prediction, then obviously you need to check what is the value of the score. So normally, if you are familiar with the regression problem as of now, we use the R2 score. And in my theory class, I explained like how to calculate the R2 score actually. If not, I'll provide the link in the video. You can check that and that will give you this result. Okay, so we are getting this value. So just by seeing, I'm not very happy with this score because it's only giving me 0.77 and R2 score it as it is growing more near to 1, that is giving me the better result. So then we are plotting this disposition plot graph and just plotting this for better reference actually. Okay, now what the plan is to do the hyperparameter tuning, because just be mindful when you are doing working on decision tree, and decision tree is very powerful algorithm. But as you all kind of by the time probably know, because I repeated so many times, that there is a high chance that decision tree can overfit, and this is kind of example of that, because you are getting only 7 7, whereas probably I have not displayed the training sets, but because it is going till the end, I'm not doing any hyperparameter tuning on the max depth and all those things, so it's kind of assuming it will be uh, overfitting. Let's do the hyperparameter tuning with some basic minimum parameters actually. And right now, my main focus is to just show you how the decision tree regression is working. I'm not focusing too much on what parameters and all those things, just high level right now. This is kind of our main parameter max step, because if I don't give this, then what we'll do, it will go like in depth till the end actually, and that will definitely do the overfitting. Okay, and then grid search CV, I'm just using the regressor parameter, cross validation equal to 5, so it will run many times. Okay, think yes. So finally I will fit the data with my train data, and it will give me at the end, it will, once it is complete, so it will give me this model actually. Okay, that okay, you ran the grid search CV using all this information, but from that I'll get the best parameter. What is my best parameter? And it will give me this because now this has the best model also, so I can use that regressor.cv actually. Okay, I use the regressor.cv. Okay, good. And then I use the X test and predict the R2 score. One more, sorry, not predict, calculate the R2 score. You predict basically Y pred and use the Y pred and Y test to calculate the R2 score. So you will get the better value. Now, if you compare, this is now 0.85. So this is basically my intention to show that why the hyperparameter tuning is so important, why decision tree can be overfit if you do not do hyperparameter tuning. Because now look, it's mentioning that okay, your max step should be 8. So that's the important thing. Don't worry about the other parameters. I will explain one by one all the parameters, what are critical parameters, what you need to use in each examples actually. Because recently I worked on a XGBoost project where we used a lot of parameters actually, and each parameter is critical to understand. So we'll go one by one. Okay. So that's all actually. Basically, after that, I'm just plotting one more time, and again, it's giving me this picture. What is my actual and predicted values graph? So that's kind of thing. So that's the way decision tree regression works. And again, remember when you are working on decision tree regression problem, this is kind of for interview purpose actually, that you are not using under the hood. It is not using Gini, impurity or entropy for information gain. It is basically calculating the variance, and then based on that it is taking the decision like which feature to select, how to split the nodes, how long it will go, and all those things. And hyperparameter tuning is very must. And again, as of now, all my examples I'm doing kind of a simple hyperparameter tuning, but in when as we grow, I will show you how to do nested hyperparameter tuning actually, nested cross validation actually, and probably that will help. But again, I think I mentioned this in the previous section also, like if you do the nested hyperparameter tuning, your compute is higher, so you have to be a little bit of do a trade-off sometimes, like what kind of parameter tuning or what kind of cross validation you want to do. And slowly I will show there are different kinds of cross validation. Right now I'm just doing a simple cross validation, which is just splitting the data into 5 split and then using the 4 split as my training and 1 split for my validation, and based on that it's giving me the best results. Okay, so I think that's all right now. um, Thank you all, and if you like it, please give me a thumbs up. Please subscribe me. Your support will help me to grow. Again, I'm telling my intention is to basically share my knowledge. And if you are new in the data science area, data science domain, try to learn it. Feel free to reach out to me. I'll try to help as much as possible from my side. Thank you so much. Have a nice day. God bless you.